So now we're going to go through a system where the outcome is a unique result. So same idea, the goal is to get the ones on the diagonal and get zeros below the ones. And then we interpret our answer from there. So notice I already have it set up in matrix form. And remember, we always keep a list off to the side. So my first move is going to be switching row 1 and row 2. So by doing that, I get 1, -1, -2, 2. Now, I'm going to do essentially 3 total operations within one matrix to kind of save some space. So I'm going to now multiply this new row 1, which is this row, which is now becoming my row 1, by -3. And I'm going to add it to the new row 2. So this value right here -3 times 1 is -3, plus 3 is 0. -3 times -1 is 3, plus a -4 is -1. -3 times -2 is 6, plus 4 is 10. -3 times 2 is -6, plus 7 is 1. Now I'm going to do -2 row 1, and again row 1 is this yellow one now, and I'm going to add it to my current row 3. So -2 times -2 times 1 is -2, plus 2 is 0. -2 times -1 is 2, plus a -3 is -1. -2 times -2 is 4, plus 6 is 10. And -2 times 2 is -4, plus 5 is 1. The next thing I'm trying to obtain is a 1 in row 2, column 2 spot. So I'm going to multiply that by a negative row 2. So the first row remains untouched. The second row will become 0, 1, -10, -1. And now if I want to get a 0 directly below that 1, if I want to get a 0 here, I'm going to add my new row 2 and the row 3 together. So if I'm adding that new row 2 with the current row 3, I'm going to get a 0 directly below, which is what we want. And then -10 plus 10 is 0, and -1 plus 1 again is 0. So notice this is, like I said, it is a unique case. So from that bottom statement, we get 0 equals 0, which is a true statement, which means there's infinite many solutions. So it is possible that you could say there's no solution. So if you get a result where you get like 0 equals 2, that, for example, would be a no solution. But we don't have that in this case. We have infinite many solutions. So when it's infinite many solutions, we have to go further from there. So I'm going to switch the screen so I have some more room to show you. So from here, we're going to assume that z is z. And we're going to kind of solve for x and y. So for my y, I have y minus 10z equals -1. I'd add that 10z over, and we get y equals 10z minus 1. For the top line, we're going to have x minus y minus 2z equals 2. And I know I have an expression for y, so I'm going to substitute that in. And we're going to distribute. So I'll get x minus 10z plus 1 minus 2z equals 2. Combining like terms over here, I'll end up having x minus 12z plus 1 equals 2. And now I need to move both those terms over. So by doing that, I get x equals 12z plus 1. So our final answer will become 12z plus 1, comma 10z minus 1, comma z. So the difference is our coordinate pair isn't going to be numerical values. They're going to have variables in it. Now, if I asked you for a specific unique solution, what I expect you to do from there is pick a random value. So let's say I want to use 2 for z. So if I use 2 for z, that means 10 times 2 is 20, minus 1 is 19. So y would have to be 19. 12 times 2 is 24, plus 1 is 25. So then you could pick any unique solution by picking a z value. So that's all. This is an example of a infinite many solution matrix.